Welcome to this do-it-yourself stargazing session. This recorded commentary will help you find your way to some interesting things in the night sky. And if you didn't catch it the first time, it's not a problem, just listen to the recording again. Before we look at the sky, it's important to orientate ourselves. You'll need to find which direction is south. You can use a compass or remember where the sun will be in the middle of the day. We will start by facing south, and I would suggest you always do that at the start of a stargazing session. It helps you remember where things are. If you look at the stars each night at the same time, you find they've all moved a bit to your right, or the west if you're looking south. Over the course of a year, they will move across the sky, down one side and up the other side, and back to where they were. This is caused by the Earth orbiting around the Sun, and it means that as the seasons go by, we see different things. The sky we will be looking at tonight is the mid to late summer sky, that is, August and a bit into September. In late September or other seasons, the stars will have moved, so this recording will not be so relevant. In August, it doesn't get dark until around 10 o'clock. That's a good time to start our stargazing session. So let's begin. Before we start, make sure you keep an eye out tonight for shooting stars. Early August is a good time for seeing them as they tend to be plentiful. They can appear anywhere in the sky and look like very rapid flying sparks. They're bits of dust from the tail of a comet that passed the Earth's orbit thousands of years ago, and they burn up as they streak through the Earth's atmosphere. If you have a good view to the south, and you can't help but notice a very bright creamy-coloured object, not very high in the sky. Nothing else is anywhere near as bright. You'll notice that it shines with a steady light, whereas the stars tend to twinkle. The fact it doesn't twinkle suggests it's a planet and not a star. In fact, it's the planet Jupiter. It's by far the largest of the 8 planets in the solar system, and in fact has more mass than all the other planets and asteroids put together. It's about 140,000 kilometers in diameter. That is 11 times larger than the Earth. It's over 5 times further than the Sun from the Earth, so it gets much less sunlight and is very cold. What you're looking at is not the surface of the planet, but the tops of an enormously thick layer of clouds. They are at around minus 145 degrees Celsius. The planet doesn't give out any light of its own. You're looking at reflected light from the tops of the clouds. If you have a pair of binoculars, have a look at Jupiter through them. Can you see the moons? Jupiter has at the last count 79 moons. Most of them aren't visible, but its 4 largest moons can be seen easily in binoculars and telescopes. If you look on different nights, you'll see that the moons move. This was first seen by Galileo Galilei in 1609, and when he saw that they were moving around the planet, that gave him a clue that the Earth may be moving around the Sun instead of the Sun around the Earth, as most people believed at the time. Now look a little way to the left of Jupiter, just a little bit higher, and you should be able to see another bright object. Not as bright as Jupiter, but brighter than the stars. This object doesn't twinkle either. It's the planet Saturn. Like Jupiter, Saturn shines by reflecting the sun's light back to us on Earth. It's even further away than Jupiter, 9.5 times as far from the sun as the Earth, and the tops of the clouds are even colder, at minus 178 degrees Celsius. Because Jupiter and Saturn are made mostly of gas, they're called gas giants. Saturn has a beautiful set of rings. They're difficult to see with binoculars unless they're large ones, but easy to see in a telescope. They are made of many ice particles orbiting around the planet. In fact, we now know that Jupiter, Saturn, Uranus and Neptune have rings as well, but they are very difficult to see from Earth. Let's look at the stars now. If you look at the sky just to the right of Jupiter, a similar distance to that between Jupiter and Saturn, if you have a good clear sky and a dark night, you may see a band of milky light arching right up and over your head. That is the Milky Way, and it's particularly bright at this time of year. The Milky Way is our galaxy, and the milky appearance is caused by millions and millions of stars so far away that they appear as a milky mist. Our galaxy is estimated to have more than 100,000 million stars. The bright stars you can see in the sky are also part of the Milky Way. They just happen to be our closest neighbours. Now let's look for some constellations. Start by finding Jupiter again, and then follow the Milky Way up until you come to quite a bright star vertically above Saturn. It has a smaller reddish star just above it and to the right. The bright star is called Altair, and it's the head of Aquila the eagle. The reddish star is Tarazed. See if you can make out the wings of the eagle and the stars to the left and the right of the Milky Way. He's flying up the Milky Way. Altair is one of the stars in the summer triangle. We can now go and look for the other two. Move your eyes up above Altair and a bit to the right from the Milky Way until you're looking almost overhead. There is a very bright star there, brighter than any others around it, and it shines with a brilliant slightly blue colour. That star is Vega in the constellation of Lyra the Harp. Now look carefully just below Vega, and you should be able to spot four much dimmer stars that make a small rhombus shape, a sort of squashed rectangle. That is the constellation of Lyra or the Harp. So now we found Altair and Vega in the summer triangle, and the last of the three is called Deneb. From Vega, start looking to the left until you reach the Milky Way, a position that is almost vertically above Saturn. You should find a bright white star. It's much brighter than the others around it and sits in the middle of the Milky Way. You have found Deneb. Deneb is the tail of the swan called Cygnus. It's flying down the Milky Way as if to meet Aquila flying up. You may notice that Deneb is part of a group of stars that form a large cross shape. The bottom of the cross represents the long, graceful neck of the swan. The two arms of the cross are part of the wings. Now look back at Vega. It's a bit brighter and a bit bluer than Deneb, but the difference is not huge. However, appearances can be deceptive. Vega is around 100 times closer than Deneb. Vega is quite close in astronomical terms, just 25 light years away, but Deneb is over 2,500 light years away. The reason they look so similar is that Deneb is absolutely huge, and it's possibly the most distant star you can see by eye. It's more than 50,000 times as bright as our own sun, and is around 200 times bigger. So now you can see the whole of the summer triangle, and you can learn to recognize it in the future, and the constellation of Aquila, Lyra, and Cygnus. If you go out to look at the stars at the same time in late September or October, you'll still be able to find the summer triangle, but it would have moved to the west, or your right, and will set below the western horizon earlier and earlier each night. Now let's look for one last constellation of the evening, Cassiopeia. Cassiopeia was a mythical queen of ancient North Africa. She boasted that she and her daughter, called Andromeda, were more beautiful than the daughters of the sea god. To punish her, the god Poseidon sent a sea monster called Cetus to ravage the coast. Now the oracle told Cassiopeia to sacrifice her daughter to the monster to appease it, but she was rescued just in time by Perseus, who was riding on the winged horse Pegasus. All of these characters are represented by constellations in that same part of the sky. But this evening we'll just look for Cassiopeia, as it's probably the easiest to recognize. To find Cassiopeia, go back to Deneb in the Milky Way. Then follow the Milky Way up and over your head, and you'll soon come to a constellation that looks like a large W. You found it. Cassiopeia is what astronomers call circumpolar. That means it never actually sets below the horizon, and you can find it somewhere in the north at any time of the year. A constellation such as Aquila cannot be seen in the winter, and neither can most of Cygnus, although the star Vega never quite sets below the horizon. So this evening we've learned how to find and identify 4 constellations, the Milky Way and the Summer Triangle. If you keep practicing finding these constellations, and perhaps use a star chart or a phone app, you'll find it easier and easier to remember them and add new constellations to your collection. I hope you'll be able to find everything, but if not, don't worry, keep looking and enjoy the wonders of the summer sky.